the series and parallel connection of battery. So today we are going to do the experimental verification of how to connect the batteries in series connection. Okay, so here you see here we are having two batteries. The circuit diagram is like this. Okay, so you are going to have two batteries like this. So battery 1, battery 2, and we are connecting an voltmeter in parallel, and we are connecting an ammeter in series, and to the ammeter we are going to connect to an variable rheostat. So to capture different voltage, current, as well as to calculate the power. So you have the tabular column to calculate the voltage, current, as well as the power. Okay, let's try to do the experiment. So this is the battery we are selecting. So this battery is 40 Ah and this battery is of 40 Ah. Already I told the rating of a battery will be in terms of what? Ampere hour. It's already written here. This is of how much? 40 Ah. Here it is written 40 Ah. So this is 40 Ah and this is of 40 Ah. What is the output of this battery? Is 12 volts. Okay, the system voltage is 12 volts. Now let's try to measure the voltage. You see here, this is negative terminal and this is positive terminal. When you connect here, when you connect here, so this is positive and negative.
So you got 12.46.
So you are going to get this voltage, and this voltage is nothing but the system voltage, 12.4. Similarly, we are measuring that voltage also. Okay, so now this is positive and negative. We are going to get 12 volts. Now what we are going to do? We are going to connect these batteries in series connection. So we have developed a scheme. So this is positive terminal, and this is a negative terminal, and this is the battery to negative terminal, battery to positive terminal. So now as per the circuit diagram, we want to test with respect to what? Series connection. The negative terminal is connected to positive terminal. You see here, the negative terminal of the battery we are connected to positive, so we have been shorted. When you short, how many terminals are left now? One positive and one negative. So this is one negative and this is the positive. So already 12 plus 12. Why? Because we connected in series. We can measure that voltage. Okay, so when you connect between the negative and positive, how much voltage it is? 12 plus 12, approximately you are getting how much? 24 volts. Okay, so now I can say that successfully we connected in parallel. So now for safety, to increase the safety, what we are going to do? We are connecting through an basic fuse protection. Already we explained you how to connect this fuse. So we had loaded this fuse maximum to 6 amperes. Okay, so the maximum current we design it for 6 amperes, and this is primary protection, this is secondary protection. This is manually the fuse will blow off. We will replace the fuse where this is called KitKat fuse. So we'll replace the fuse leg and we'll replace it, and we'll insert where this is called manual fuse. This is an automatic fuse. So for example, if any problem occurs, automatically it will fall down. So there's no need to rewire it, automatically can turn on. So that is called MCB, miniature circuit breaker. So now we connected battery 1 and battery 2 in which connection? Series connection. We increase the voltage from 12 plus 12, but the resultant voltage you got from these two wires, 24 volts. So now I'm connecting this voltmeter. See the diagram, you can understand. We are going to connect the voltmeter in parallel. So we have bought the two terminals here. So this is one negative terminal, this is nothing but the positive terminal, and we kept the isolate which connection? MC pin off. Okay, as soon as you turn on it, you see here how much voltage is increasing. So approximately 12 plus 12, 25 into 1. Approximately, since it is open circuited, it is giving higher voltages. This is how much? 25 volts. Okay. So now here from here, so we got the resultant positive. From this positive, we are connected to the positive terminal of the ammeter, and output of the ammeter we are connected to the rheostat input. The rating of this rheostat is 50 ohms and maximum current is 5 amperes. Okay. So output of this is connected to once again to the negative. Okay, so now we closed the loop like this. Okay, so we connected the output of the battery to the ammeter positive, and ammeter negative we connected to the rheostat positive, and rheostat negative we connected to the closed. So you can see here the loop is closed. Yes or no? So now we are going to take different set of readings. See your manual how to take set of readings. First one is serial number, second one is voltage indicated in the meter, so third one is current indicated in the meter. So after that we have to do the product of voltage and current. Then you can understand how much amount of power they can supply. Okay, let's try to do it. So actually when you connect in series, only ammeter reading is more than sufficient. Why? Because we want to check that these two batteries are connected in series. That's why if you directly measure the voltage, it is sufficient. So but what we are going to do is we are going to load it. Okay, already in the class we have been told that this is of 2 volts, this is of 2 volts, and this is of 2 volts. Okay, like this, how many cells you have? 6 cells. 2 into 6, 12. That's how it is generating 12 volts. Okay, so the internal chemistry, how to test the health of this battery by using battery tester, how to check the gravity level, we'll do by next experiment. Then you can understand better. Okay, now to try to write down 2 readings. So first reading is, you can see here, voltage is how much? 25 volts. Write down serial number 1. Voltage is 5 volt, 25 volts, and current is 0.25 amperes. Okay, if you multiply it, you can get the power rating of the load you can connect. Okay, so now you see here, I'm slowly increasing, reducing the rheostat. Now what is the position of the rheostat? Maximum resistance.
You have to keep that at maximum.
Now we are bringing to the minimum. When you decrease this, automatically what will happen? Current will increase. You see here, now I am reducing the rheostat. You can see here it is starting with 0.25. Okay, so see the voltage reading.
So reducing the resistance means current will increase. So that you can notice on the ammeter.
Write down the current is 0.25. Current is 0.25. Voltage is 25 volts. Next reading we are taking. So be careful. We'll take only 2 to 3 readings. Okay. Why? Because we are going to fully load. Write down. Current is 0.5 amperes. So see here, we are connected to the base scale only. Okay, so we are connected to the upper scale 2.5 into 2. Scale those values 0.25 into 2, and now latest value is 0.5 into 2. Take the voltage value is how much? 24 volts. So as soon as you increase the load, what will happen? Voltage regulation, voltage will fall down. Okay, next, we are taking the next set of readings. Take the next reading, 0.75 into 2. 0.75 into 2. Current. Voltage is 24 into 1. That's into 1. Okay. So next set of reading we are taking. So directly we are going with 0.9. Write down. Current is 0.9 into 2. 0.9 into 2. And voltage is 24 into 1. So we are not loading more. Why? Because it's getting overloaded. Okay. So we don't want to damage the equipment. So we are taking the at 1 ampere. So write down the current 1 into 2. 1 into 2. The next reading 1 into 2. And voltage is 24 into 1. So next reading we are taking 1.25 into 2. 1.25 into 2 is the current, where voltage is 23.8 into 1.
24. Just below 24. You can see that.
23.8. Okay. So we are taking the last reading. We are not going to load the equipment much. 1.75 into 2. 1.75 into 2, and the voltage is, we are going to get it as only
23.64. 23.64.
So we are not going to more deeper.
Better you go for digital meter so that you can get a very clear clarity on the values what you are seeing.
So now we have loaded the rheostat to the minimum. So here we have the maximum load. We are trying to bring it to the minimum. Okay, we are not trying to load the full. Okay, so we have brought it to which value? Now the resistance position is what? Maximum. Therefore current is minimum. So after loading you have to come to the initial condition and you have to make the ammeter current as minimum value, and then what you have to do? You should turn off the MCB. Okay. After turning off, what you can see here, the way to start the experiment. How to start the experiment? Again. So already the connection is there, you turn on it. Okay, automatically this is connected in parallel, voltage will increase, and this rheostat in which position? Maximum. So this is how to start and stop. You have to learn it. So you should not stop at this position. Why? Because the complete load will be available directly, and there is a chance of the equipment to damage. And the next student, next batch cannot.
Also short circuit. And one more, the main precaution what you have to choose or what you have to take care while doing this experiment is never short circuit a battery with known or unknown. That's the reason why we are giving this protection for this circuit. Okay. So a direct short circuit, it leads to sparking and it leads to a firing, or even it leads to a severe shock, burning of your fingers. So to avoid that, You have to be very careful while doing this type of experiments. Okay.
And one more, we may ask, sir, how you design this fuse rating? Okay, let us try to take these batteries are connected in series or parallel? Series connection. What is the resultant AH rating of the system you got? 40 AH. Let's try to take, I'm taking a backup of 10 hours continuous. Okay, so 40 AH divided by 10 hours. Okay, so 40 by 10 is how much? 4 amperes is the maximum current I'm taking to flow. So 4 amperes into how to design this fuse rating multiplied with 1.25. So when you multiply it, this will be how much? 4 into 1.25. Approximately you will get how much? 6 amperes. I mean 5 to 6 amperes. That's why 5 amperes. That's why we connected the fuse of how much rated? 5 amperes. I mean 5 to 6 amperes range. And so if the fuse fails, we are using secondary backup with MCB with 30 amperes. So it can work, which can up to how much? 30 amperes. So basically this will blow off. If it fails, this will help us. Okay. So that's how to decide the ratings of the fuse. You may get doubt. Sir, we have been designed all the system. How we designed? So all the time the fuse selection you have to make the original rated current into 1.25. 1.25 means 1 means 100%. 0.25 means 25% extra fuse capacity and